Hi, hello, and welcome to Math at a Go. Today we are on the second day of our 18-day action plan with the chapter called Sets. Today, instead of explaining the lesson first and the questions next, I have prepared the questions so systematically that doing each problem gives you the overall knowledge of the chapter as well as your ability to solve any problems concerned with this chapter. So let us go problem by problem. Before that, I would like to say one thing. This is the easiest chapter. Go and ask anybody which is the easiest chapter in 10th class. Everybody, at least 99% of people say it is sets. So this is the easiest topic, and if you are well with this chapter, you are sure to score easily from 6 to 7 marks from this chapter. And since it is easy, we should not lose a single mark from this. Coming to the first question, A is a set with world's 3 best books as its elements. Write its elements. So now we have to write the set A. We use capital letters to represent a set inside this braces. Now whatever are inside the set, they are called the elements. Now what are the elements here? The world's 3 best books. World's 3 best books. So shall we write them down? Is it 10th class mathematics textbook? Or is it your favorite Sunday magazine? Or Sports Star? What is it? We can't say, because it varies from person to person. What is best to me may not be best to you. So the best books are not properly defined. So this is not at all a set. So you cannot write this set, because set should be a collection of well-defined things. That means if an article is given, you should be able to say whether it belongs to that or not. Here we cannot say whether Star Sports belong to this or not, whether Sunday Magazine belongs to this or not. We cannot say. So this is not a set. And in a set, the things are called elements. They must be distinct. You should not write a single element repeatedly. For example, if you have to write 3 books, for example, Sunday Magazine is the best magazine. Now you can't write Sunday Magazine, Sunday Magazine, Sunday Magazine. It is not that. You should not repeat the elements. That is why we say a set is a collection of well-defined, distinct objects. So the objects must be distinct. That means different. One element should not be repeated. So this we cannot write, because A is not at all a set. Coming to the second question, S is equal to 5, 6, 7, and it is given 8 belongs to S. Do you agree? Why? When you have elements in it, whatever are the elements present in this set, we say this element belongs to S. So 5 belongs to S, 6 belongs to S, 7 belongs to S. So here 8 belongs to S is given. Is 8 there in the set? No. So we say 8 does not belong to set. So what is given is not right. So we don't agree with that, because 8 is not present in S. If it is present, we say it belongs to. For example, we say 7 belongs to S, but 8 does not belong to S. Now coming to the third problem. How can you express V is equal to A, E, I, O, U in other way? So this is one method of expressing, where we express all the elements separated by commas. This is called roster form, wherein you write all the elements separated by commas. Now can we write it in any other form is the question. Yes. If you look at that carefully and observe them, you can understand one thing. They are all the vowels of English alphabet. So the common property is all of them are the vowels of English alphabet. So that is how we write it. So V consists of all X's, such that X is a vowel of English alphabet. That is how we write. That's it. So this is called set builder form. Why? This is telling how this set is built. Hence the name set builder form. Now coming to the fourth problem. M is equal to x such that x is equal to 1 by p square, where p belongs to n and p is less than 6. So let us see how we can write this. This is set builder form, and now we have to write it in roster form. How can you write? Let us see. So the name remains the same, m. So m is equal to some elements separated by commas. So what are the elements? They all have x's. So what is x? 1 by p square. So it is something 1 by something, 1 by p square. But what is p? P is a natural number. What are natural numbers? Represented by n. 0, 1, 2, 3, 4, so on. The whole numbers presented by w. Dash dash dash, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. The integers represented by z. All these and numbers in the form of pq, where q is not equal to 0. That is natural numbers, whole numbers, integers, fractions, decimals, terminating decimals, non-terminating repeating decimals. They are all the rational numbers represented by q. Now root 2, root 3, 0.1234792 non-repeating, non-terminating decimals, they are all called as irrational numbers written by q dash or I. Now these together, q and I together are called real numbers. So all these numbers come under real numbers represented by the letter R. So depending on this letter, you have to understand what is given there. So here it is given as n. So what you write? You write something here and square it. You see, x is in the form of 1 by p square, and p is what? A natural number. So you write the natural number 1, 2, 3, 4, 5 and square it. So, and what are the limitations? The limitations are it is less than 6. So natural numbers begin from 1 and go on without end. But you have to take the numbers only up to less than 6. So less than 6 means not 6. So all these you have to take and go on squaring. So 1 will be with 1 square, the other will be 2 square, the other will be 3 square. You have to go on up to 5. The other will be 4 square, the other will be 5 square. But you can't write like that. You have to simplify and write. So it will be like this. 1 by 1 square is nothing but 1 by 1. You can write it as 1. So 1 by 2 square is 1 by 4. 1 by 3 square is 1 by 9. So 1 by 4 square is 1 by 16. 1 by 5 square is 1 by 25. This is the roster form of this problem. Coming to the fifth problem, he has asked you to give an example for set phi. What is a phi? A phi is a null set. What is a null set? A null set is that set which has no elements in it. Can we have such type of sets also? You said a set is a group of, a collection of objects, and now you say no collection. Yes, sometimes there may be a day without any collection, like that. So let us see. A phi is a null set. That means it has no elements. So both can be used to represent a null set. Let us take an example. So we often hear people saying, I shall give you a grand party on this February 31st. Because February 31st doesn't exist at all. So there are things which you name but they don't exist. So such type of set is called a null set. Let us take an example. This phi, for example, you can give other names also. For example, is x such that x is a natural number. So in this group, all the numbers from 1, 2, 3, 4, 5, so on they come. And x is less than 1 if I say. So they already start with 1. So less than 1, you don't have any natural numbers. So they're all natural numbers but less than 1. Less than 1, no natural numbers are there. So it is simply an empty set, a null set, a void set. So this is an example. You can also say like this. X is such that x belongs to w and x is less than 0. That's it. You might have heard a joke. A devotee comes and stands before the God. Standing before the God says, oh my God, with your blessings I have earned so much, and in gratitude to your blessings I would like to offer you so much. Take as much as you want and give me whatever you feel. So I am throwing all these coins into the air. So take away all the coins you want and only throw me some coins which you can, and with them I would live happy. Truly speaking here, how many coins can lie really in the air? No coins. That means the number of coins that can be taken by the god are zero. So there are no coins to be taken by the god. So here the coins taken by god is a null set. It has no elements. Now coming to the sixth problem. Can you guess and write the universal set for the sets A is equal to 1, 3, 5, 7, 9, B is equal to 2, 4, 6, 8, C is equal to 2. Now he is asking us to guess because there are many chances for that. So he is asking us to guess. So how can we guess? He is asking us to guess the universal set. So what is a universal set? A universal set is a set that has all the elements speaking at that particular moment as its elements. So in this, these all will be the elements. That means for this, these all will be subsets. So what is a subset? We'll go in the next problem. So it should have all the elements. So 1, 3, 5, 7, 9, 2, 4, 6, 8. 2 is already mentioned, not mentioned? 2 is mentioned here. Okay. So once it is mentioned, you need not mention. So this is a universal set. And it can also have more. So if you observe properly, it is like 1, 2, 3, 4, 5, 6, 7, 8. For a clarity, you can write them like this: 1, 2, 3, 4, 5, 6, 7, 8. You can also write 9 and 10, 11, 12. You can write to any extent, it is your choice. But this is minimum. And the more are of your own interest. So this forms a universal set for the given situation. That means universal set changes from problem to problem. In this problem, the set having numbers from 1 to 10 may be universal set. But this may not be a universal set in some other problems where 11 and 13 are elements as some other set. So it depends from problem to problem. And a universal set is denoted by capital U or otherwise Greek letter mu. So both of them can be used to represent universal set. While drawing Venn diagrams, we use rectangle generally to represent universal set by writing U or mu anywhere, no problem. And if I write a set like this and say it is universal set, it is not accepted. Why? Because the element present here, 8, is not present here. So this is not a universal set for this. So it should have more elements. All of these elements must be there inside this. In addition to that, also there may be some more elements. That is a universal set. Coming to the seventh problem, write all the subsets of P which is equal to 3, 5, 7. Now, what are subsets? For example, if there is a set having 3 and 5, so all the elements present in it are present in this. So this is a subset to this. Now if there is another set having only 3 as its element, then does this become a subset to this? Yes, because all the elements present in this are present in this. So this is a subset of this. So how to write all the subsets? Let us see. So it is just like evolution. So first you write the set. So empty set is a subset to any set. In the next stage you will go on writing the elements one by one. So it will be 3, it will be 5, it will be 7. So once you write the empty set, you will go on to write one element each time. In the next time you write 2 elements each time. So 3 and 5. Next 3 and 7. So take this with this and then next 5 and 7. Now can we write 7 and 3? If I write 7 and 3, this is nothing but this one, because in sets the order of elements is not important. So 7 and 3 and 3 and 7 are both same, so you should not write it. Now you wrote the empty set which is a subset to every set. Next, sets having 1 element each time, sets having 2 elements each time. Next you will go for set having 3 elements, so it will be 3, 5 and 7. There are only 3, they can be only written once. So now all these are said to be the subsets of P. Let us check whether they are right or wrong. This has elements 5 and 7. Are they present in this? Yes, 5 and 7 are present. So this is a subset to P. Now let us check this. 3 is there. Is it there here? Yes, it is there. 5 is there. Is it there? Yes, it is there. 7 is there. Is it there? Yes. So all the elements present in this are present in this. So this is also a subset to this one. Now all these are called the subsets of the set P. Now how many are there in all? Let us check. 1, 2, 3, 4, 5, 6, 7 and 8. So it has got 8 subsets. Do we have any technique of finding how many subsets a set can have? Because when the elements are only 3, it is easy to write. But if the elements are 5 or 7, it becomes hard and you may miss at some time. So it is better that we know some formula. So there is a technique. If a set has n number of elements, then 2 to the power of n represents the number of subsets a set can have. For example, here the number of elements is 3. So number of subsets it can have is 2 to the power of 3. 2 to the power of 3 means 2 multiplied 3 times 2 to the 4 to the 8. So it has got 8 subsets. We counted them and it is right. So this is how we have to check. Now, if you put them all together, separated by commas, and put them inside a big braces, writing in the sequence, then this set is called the power set of this set P. The power set. What is a power set? The set having all the possible subsets of a given set is called the power set of that given set. Now coming to the 8th problem, it is given as n of 5 is equal to 0 within the cell brackets and n of 5 is equal to 0, which is right and why. Now what is n of? N means number of. So n of 5 means number of elements in the set 5. For example, if it is n of A, what does it mean? Number of elements in the set A. For example, if A has 2, 10, 50. Now how many elements are there in all? 1, 2 and 3. So the number of elements in set A, n of A is equal to 3. So this is n of A. Now the question is n of 5. So number of elements in 5. What is the 5? A null set with no elements, with 0 elements. So number of elements in 5 must be equal to 0. So what is this? Is it a number or a set? Whatever is written inside the braces, it is called a set. Now set is a collection of things. Here we are speaking of number. This does not become a number. This becomes a set. So we should be only able to write number. So number of elements in 5 must be simply written like this, but not like this. So this is right because this should not represent a set. This speaks of number, not set. So this is right. Coming to the 9th problem, this also appears to be of similar kind. So what is given? 5 is equal to this one, which is equal to 5. This is equal to 0. Is it right or wrong? So 5 means a null set. So 5 is equal to a null set. This is accepted. That means there should not be anything in these brackets, even not the dust. So this is right. But here we have this 5 inside it. This 5 is an element now. It is not a set. It is an element now. So this is a set having this as element. That means there is one element. But truly speaking, there should not be any element. So this is not proper to write like this. This is wrong. Now what about this one? So this is right. This is wrong. Now let us see this one. So 5 is equal to 0. Is it right? So what is 5? It is actually a null set with no elements, with 0 elements. But that doesn't mean you should write a 0 inside the bracket. This means there is an element 0 in this as element. So this has one element inside it. Maybe it is 0, but there are one elements we say. But As per the definition, 5 should not have any elements, but it has one element. So this is also wrong to write like this. So you should not write like this, you should not write like this. Good luck.